Hello. So today we will verify the superposition theorem. This theorem states that if we sum up individual contributions of each sources in a circuit, we will get a total response. For example, we have this circuit and we want to find out the value of current I3 flowing through R3, and we will obviously use the superposition principle. So what we will do is we will keep alive only one source, which is, let's say, E1, and we will kill E2, so we make it 0 volt. So this becomes 0 volt and this becomes a single wire. Now we will calculate the current flowing through R3. Let's say we get I3 equals some value and we name it I31, some value. Next, we will do the same for second source, which is E2. We'll keep this alive and we'll kill the first source E1, make it 0. So this whole thing becomes a single wire since it's a 0 volt, so no voltage difference. And we will measure the I3 again flowing through R3. And now let's say we get I3 2, which is another value. So the superposition theorem says that we will get total I3 if we add up these two individual values. So total I3 is the total contribution of both the sources together. So that's the full principle. Let's see in our simulation software. What we need is we need voltage sources, cells. We need 2 of them, and we need resistors. We need 3 resistors. Let's place them here. Rotate this like this. And we need 1 ground. So now when I connect this, let's give values of our R1 to be 300 ohms, R2 to be 400, and R3 to be 700. And let's make V1 10 volt and V. So this is our circuit, and first of all we will kill the V2, so make it 0. So this becomes no voltage source in the right side. And if we now simulate, okay, so our simulation is complete, and if I see the currents here, so you see the I3 is 6.557 milliampere. I3, so first time measurement, we get 6.557 milliamps. Now we will change V2 to its original voltage 20 volt and deactivate V1, making it 0 volt. So V1 is now killed or deactivated, and we will have the sole single effect of V2 in I3. So let's simulate this again. Okay, now we see 9.84 milliampere in I3. Let's write it down. I3, the second time we're getting 9.84 milliampere. 9.84 milliampere. Now we will simulate both together. So if I simulate this both together, I get 16.39 milliampere. So I3 total equals 16.39 milliampere, which is obviously the sum of the first two individual contributions of the voltage sources. And thus the superposition principle is proved here because the individual contributions are equal to the total. And hence we have verified the circuit. So that's all for this experiment. Thank you.